As with question 3, I tried to simplify this a little bit by giving you a little bit less complex of an example to get to the same point. So again, when I say use model structures, I'm trying to help you not get distracted by the size or number of functional groups involved that don't actually do anything in reality. So I stripped off a lot of the alcohols here in getting to the simple version of what I have here at the bottom right, our model version for the ribose hemiacetal. Just an FYI, the furanose form is what it's referred to. The five-membered ring form of sugars is called the furanose form because this is furan. So it's a five-membered heterocyclic ring with an oxygen in it. So what I have instead is just the aldehyde and the terminal alcohol of a chain. To make ribose for real, there'd be alcohols on every carbon. That's how you end up with this one, and this one that are not used for the reaction. They're just there supplemental to the structure. So let's talk about how that works. So first, anytime we have acid present, we're protonating something. The carbonyl is a better base than the alcohol. So it is going to get protonated first, and that helps us because we need to weaken that pi bond to make it susceptible to mediocre nucleophile, which is what the alcohol is. Now it's weakened. Now I could draw a resonance structure putting a cation on the carbon. I'm not going to do that, but you can look back at the lectures and see it there. So then we can get attacked by a relatively weak nucleophile. And we now have our ring. We now have a five-membered ring where the oxygen that closed the ring up was the alcohol, so it still has a hydrogen on it. The pi bond had an OH on it, had a hydrogen on it as well, but now is neutral, no longer has a charge. That positive charge is gone. Now something, whether it be water or another molecule of the aldehyde, but something is going to act as a base here. For just simplicity, we'll draw it as water. And neutralize the structure. That's all there is. Most of carbonyl chemistry is relatively short. Acetal formation from start to finish is a little bit lengthy to draw out, but the individual steps to get there, this is a halfway point, is relatively short and sweet. Common mistakes, removing this hydrogen. Just no. No. There are no bases that we're going to use to deprotonate an aldehyde, period. In practical terms, ever.